boys and girls. Time for another, oh, and dad too, right? So I would like to start off this week, week number 3, with the normal curve. And this is the basis for the whole class. So if you understand nothing else, you have to get this lecture and you have to understand it or we can't move on. So for right now, I want you to think about when you say standard deviation, average distance to the mean, average distance to the mean. So when we have a mean here in the middle, the mean, right? The mean is the average score or the average of all the scores. Okay? But not often does something fall right on the mean, and you want to know where is the rest of the data. Okay? So the way that the normal curve works is that it accounts for data regressing to the mean. What's that mean? All data regresses to the mean. Okay, it's true. Okay, so think of your test score. Let's take Miranda, and Miranda gets a 96 on the first test, and she's thinking, gosh, I am really good because we're on a 4-point scale, so if I got 96, I've got a really good score. Okay, so she gets a 96, and let's say Heidi, she gets a 52 because she doesn't study and she sleeps in and she thinks, I'll get it later. And she's going to be the retake kid, okay? So we go and we take the second test. Now, Miranda has very little margin of error to keep her mean in a 96. Whereas Heidi, you get a 50 for being alive. Pretty much she's going to probably score better than a 52 by just simply being alive. So Heidi's going to climb, maybe she gets a 70, okay? And that makes her average in the 60s, right? But Miranda, even if she gets a 94, her average has come down and it's come closer to what the mean was. So Heidi, on the negative end, came in and she's going to get closer and closer to the mean this way. And Miranda was way out here and she's going to regress back this way. Does it mean you shouldn't try? No. But it does mean that most things in life regress to the mean. So whenever you see data, I always say, let's wait, okay? Because if we collect enough data, it'll all regress to the mean. And the reason that we know this is because that with enough data sets, enough data points, observations, like my class of 25 last week, right? I had this class of 25. If you get enough data points, everything regresses to the mean. Everything fits on a normal curve, okay? It might be skewed, but it's gonna fit on some kind of normal curve, okay? So today, we're gonna look at the average distance to the mean. So the data I took in was here, okay? So this is the June data for those tortoises we measured last week, okay? So these are Cassuela tortoises. They're probably about 3 years old. This is the June data, okay? And the mean was 17.1 centimeters on the Largo curva. Remember, they gotta be 28 centimeters or they can't be let loose, okay? And the standard deviation is 2.5. Well, we need a standard normal curve to understand what this means, okay? So if I make my mean here 17.1, okay, and one standard deviation above, so I take one standard deviation and I add it to the mean, okay, I get 19.6. And if I add 2.1 to that, or 2.5 to that, okay, I get 22.1. We're not going to go 3 for now. We're just going to stop at 2. 3 is for that's another day. Okay, we're just going to go 2 standard deviations out. Okay, so now if I take 2.5 and I subtract it from 17, I get 14.6. You can do this on your calculator. Okay, I'm usually right, but sometimes I make a mistake. If I subtract 2.5 again, because this is one standard deviation below. So if I take 17.1 and I subtract 2.5, okay, I get 14.6. And that goes here, because it's one standard deviation less than the mean, okay? Whereas 19.6 is one standard deviation more than the mean. If I subtract 2.5 again, I get 12.1. Okay? So I know, okay, that 95% of the data is going to be between 12.1 and 22.1. So that's going to be the average size of this tortoise group. All right, now, how do I know that? In the normal curve, the way the normal curve and the standard deviation works, that average distance to the mean formula works, is that I know that within one standard deviation of the mean, I have 68% of the data. 34% of the data is from the mean to 1, okay? I have 34% of the data that's from the mean to -1. So 68 here, 68% of the data is going to be within one standard deviation of the mean. Okay. So over half your data, well over half your data, 2/3, well over 2/3 of your data is going to be within one standard deviation of the mean. Now, if I want to see what's within 2 standard deviations of the mean, there's 13.5 here and 13.5 here. And that 13.5 plus 13.5 is 27. 27 plus 68 is 95. So with the green here, so if I get out my green pen, 95% of the data is going to be within 2 standard deviations of the mean. Okay. So I know that in my data set, the tortoises are going to have 95% of the tortoises are going to have a Largo Curvo between 12.1 and 22.1. Good? Okay. So if it was 3 standard deviations, then we account for 99% of the population, but we're never going to do that. We're going to stop right here with this. Okay? So, what I want you to do this week is to take the September data, okay, and come to class with the numbers figured on your normal curve, because I'm going to do one more step here, okay? So I'm going to take one of the tortoises and I'm going to see how far away they were at the mean. So I have to find my calculator. Woo, fancy calculator, okay? So let's take our tortoise that was 19.1, okay? So I had a tortoise that had a normal Largo Curvo of 19.1, okay? Let's write him in blue. So if I look at my normal curve, 19.1 would be about right here, right? Okay, because this is 17.1 and this is 19.6, so it's almost to that 1. Okay, so here's my little tortoise that had a measurement of a Largo Curvo of 19.1. Trying real hard to get to 28 so he can get out, be wild, and, you know, throw parties and stuff, and not socially distanced. So here's my little tortoise that's going to be like, holy cow, I'm growing, I'm trying to eat enough, I'm trying to do it, okay? About what percentage of tortoises are smaller in his corral? About what percentage of tortoises are smaller in his corral? Okay, 2 ways to do this. Okay, I want to teach you once with your eyeballs, because your eyeballs are really important in my statistics class. If you can see it and guess at it and tell me how you guessed at it, I'll give you all the credit in the world. Okay, so 19.1. Well, I know half the data is over here, right? Because that's the line in the middle, right? My 2 boards here, this is the people who are below average. These are my tortoises that are above average, okay? So I guess they're tortoises, and people will know they're tortoises. They're all tortoises, okay? So these tortoises are the small tortoises, and these tortoises are the large tortoises. So at least 50% of them, right? Okay? Easy peasy. So then I'm going to go, and I know there's 34% in here. And I know that most of this is here, right? Most of this is here. And the curve comes down so that there's fewer tortoises from here to here than there is from here to here, right? Because it's a frequency going up. So I might guess that there's just about 30%. Like he's got just 4% of the tortoises are between where he is and 19.6. So I'm going to say 30 is in the shaded area here, right? Okay? And in this area right here, I'm going to say, oh, there's just 4%. Okay? So 30 plus 50 is 80. So this tortoise is about the 80th percentile in growth. Okay? Good? Okay, now there's a way to do this more precisely, and that's what we're going to do today. We're going to work on something called z-scores. So a z-score is the score you're looking for minus the mean divided by the standard deviation. And in order to do that, I pull out my 1985 TI-30XA. It was $14.99 in 1985 at Kmart, okay? Thing still works, no batteries included, so it's just works on nothing. So it's the best thing ever. So I have this kind of silly calculator, so it's totally stupid, but it's kind of stupid. And I'm going to take, well, what was the score I was looking for? Right? So I was looking at a score of 19.1. That's just the tortoise I pulled out randomly. And the mean is 17.1. And the standard deviation is 2.5. So if I take 2 divided by 2.5, I get 80. I get 0.8. Well, it's not really 80 though. Okay, it just worked out that way this time. Okay, but it's not always going to work out that way. Okay, so this says I'm a standard score of about 0.8. So instead of using the numbers, now I can just go over about 0.8 in the data here. Okay? 19.1 goes down here with the real data. But on the standard scale, it's about 0.8. Let's take a different tortoise and let's see what we have with a different tortoise and see what if you can do it by yourself. Okay? Oops. So let's take a tortoise that is 13.6. Okay? So I have a tortoise that's 13.6 centimeters. A little on the small side. Probably born a little late in the year. Probably trying to catch up with the friends. Probably a female. Probably getting pushed off the food, right? So my score, X, is equal to 13.6. I have to write these things down because I'm old and I forget. Okay, so 13.6 minus the mean, 17.1, divided by 2.5, which is our standard deviation. Okay, so let's take our not so fancy calculator, our TI-30XA, and we're going to go 13.6 minus 17.1 equals, and I'm going to divide that by 2.5. and I get negative 1.4. Okay. So far so good? Okay, so it's negative, so let's go with our red pen here. One of you is colorblind, I can't remember which one of you, but if this is confusing to you, I can go in one color. Okay, you just stop me, I'll do it, okay? So, negative 1.4, so I have negative 1 and negative 2. Where is 0.4? 0.5 would be right in the middle, so it's not this way, because that would be 0.6, right, or 0.7. It's closer. So negative 1.4 is about right here. Okay? All right. So I know 50% of the people are better than them for sure, right? No problem. I know the next 34% are definitely better. So I know there's 84% that are going to be bigger than this tortoise. Now, 0.4 of 2.5. Can't do a straight percentage on this. So it's always a little bit of guesswork when we're using our eyeballs, okay? So I'm going to say so we're looking at 13 and a half. 7 would be about half. It's probably on the small side of that. So why don't we just call it 6? Okay? 6. Okay? We're going to call 6% here. Okay? So I have 50 and 34 is 84 and 6 is 90. 90% of the tortoises are bigger. So only 10% of the tortoises are smaller than this 13.6 centimeter tortoise. See how I did that? Okay, so for Monday, Tuesday, or Wednesday, whatever day I have you on all 3 days, okay? I want you to come with the September data loaded into your calculator, okay? And then we will do some z-scores with your September data. We're getting close to doing our own measurements, so we're getting real close, okay? So for Monday, Tuesday, Wednesday, okay, run to the tortoises, and I will ask you, which tortoise did you run? Eduardo? Eduardo the tortoise, right? Eduardo, give me a tortoise. Give me one of your tortoises. What was their measurement? What is their z-score? What percentage of the tortoises are bigger or smaller? Either one. Tell me either one. Okay? So I look forward to seeing you this week. We're going to practice this over and over and over, but it's really important that we be on the same page when we meet this week. All right. Have a good weekend, boys and girls. See you.